and make, you can polish that, and you've got terrazzo, which here's an example of some polish with some just gravel. I just mixed gravel into it. You can mix also, this is a polished version which has got sand in it, so it's like a replica of a tile. So pass those around and mix a bit of colouring into that one.
So it's harder than concrete, yeah? It's harder than calcium.
Yeah, it can be. Or at least that's hard. It's not as hard as geopolymer. This one here is a sort of an example of a potential sort of panel system. So it's got hemp fiber mixed into this plaster, which has also got Merv's dolomite in it. And then the panel itself is just chopped hemp, whole stalk.
What binds it together?
The sorrel cement. So the sorrel cement is the glue that sticks the hemp together.
Yeah.
And it's also the glue that sticks the fiber together to create the hard, high density surface.
Which is water resistant. Is that water resistant?
I've had things sitting out in the weather for like 5 years and they're still pretty much the same. But if you leave it in contact with the ground, you can get problems, which is why I went over to geopolymer. So yep, kind of anything that's got, so that mag board that people are using for building has got the same ingredients and fiber. So I had a sample of that, but it was a bit of a fail, so I didn't bring it. I think somewhere around. Okay, so that's sorrel cement. And then the other, so the problems with sorrel cement that I encountered was that it's not really 100% water durable. So I learned about geopolymer and knew that it was, so geopolymer was sort of discovered by a guy called Joseph. Oh, there's one there. Yeah. I'll get to that last. Not that one. So geopolymer was sort of discovered in the modern world anyway by Joseph Davidovich, who was looking at the Giza pyramids, and he had this eureka moment where he worked out that those blocks were cast in situ, right? So they basically put up boxing and poured in the ingredients up against the last block. So that's why you can't, there's no gaps between them, is because they're actually cast up against the last one. And so then he did some chemical analysis and basically proved it. He also found a hieroglyph with the recipe. When you break it down, it's got the recipe. And then he made some, and they're identical to the ones in the pyramid, and it explains all the variations that you get in them. It's just to do with how much water is in there when they mix it, stuff like that. So then he developed the Geopolymer Institute and developed the whole science of it, which is sort of the science of silicates and working with silicates, which are very similar to carbon. So organic chemistry is all to do with carbon, and carbon can make 4 bonds and can form chains, and silicon is directly under it on the periodic table, so it can also make 4 bonds and form chains, which is what rock is, or most rock, a lot of rocks. Diamonds are carbon.
What's his name?
Joseph Davidovich. Okay, so you can combine the geopolymer resin like with sorrel. You can combine it with all sorts of different ingredients like clay, sand, paper, fiber, depending on what properties you want. So, but it's got some amazing properties, like it's fireproof up to over 1,000 degrees. So you can make stuff that goes in kilns, like you can, and people are making stuff like that. It depends what you mix into it. If you put burnable stuff in there, of course, that'll burn out. But if you put stuff that doesn't burn in there, like sand or clay, or gravel or rock, it doesn't burn out. And certain fibers, like glass fiber, you can put in there, won't burn out. So you can make refractory materials. So these properties make it ideal to include in building. And so that's what I've been doing, is just working out how to use it for building. And I've brought a few samples along just to give you an idea of some of its properties. So these are fun. This one here, I've just basically bound these two bits of wood together so you can sort of do a bit of a strength test. And it's actually only 2 days old, this, but it's already set hard, and so you can have a feel of how hard it is and have a go at breaking it. And this one is the same, but this one has actually just got raw hemp fiber.
So it's just sitting on top of the Andrew. It's not actually, there's no screws.
There's no screws, no nails, and that's one of the things that I want to do in building with this stuff, is be able to build without metal.
Wow.
And be able to build without wood.
Yeah.
So it's like all the ingredients are basically out of, either hemp or out of the ground, sort of thing. And there is a bit of energy that goes into it. But you get all that back, because hemp is one of the best sunlight collectors. So it's like a giant solar panel collecting sunlight. And that balances, say, the gases that are released when you burn, because you have to burn the clay. The clay that it's made out of has to be heated to 750 degrees. And it's also got another additive in there, the water glass, which has to be made as well. But I would use this mainly for plasters and cladding, and also places where you're in touch with the ground, and anywhere you want to toughen stuff up. So pass that around. That one there's just raw hemp fiber off my own hemp. I grew a couple of crops of hemp, and I've been making a machine to sort of break it down, to break the stalks down into fiber and hurd, and then I've incorporated that fiber into there. And this one here was my original one that I made, and this is still going. And this is just a bit of like baby's nappy that was torn, dipped in some sorrel cement, wrapped around here, and I left it. And like no one's been able to break this.
Sorrel cement?
And like it has taken my weight, sort of thing, like it's pretty strong. This is a nice one. This is used incorporating the granite, rotten granite that you get from sort of Pohara, Terracoa area, mixed with geopolymer, cast and then polished. And it's my sort of attempt at making a replica granite. Yeah, you can sort of try and stick your fingernail into it. Don't drop it on the floor. It's brittle, yeah, it's waterproof. And these two are examples that are made with geopolymer and
It does look like granite.
dolomite, nerve solid dolomite. So I'm finding that to be a really good additive. And it's another thing that's local. We also have a local kale and clay mine. So that was one of the reasons I wanted to make geopolymers, because I wanted to make it out of something local. And we have to, at this point, we have to import the other ingredient, but we will be able to make the precursors locally. So we'll have a complete local building material. So you can cut those around too. And this is a geopolymer binding hemp hurd in here, and then I plastered each side with geopolymer plaster as a sort of example of what you could do to make a structural insulated panel, like what Brian was talking about before. So this is what we're going to be working towards. Well, this is geopolymer and hemp hurd. This is geopolymer, hemp hurd, and dolomite, and this is just geopolymer and dolomite.
So the idea being is that, just to clarify, instead of heatcrete, there's an infill wall material, which is autumn. The geopolymer combined with heat, or each the other things, is suddenly a load-bearing structural building.
That's what we're working towards. Can't promise anything right now, but that's what we're going for. And so this here, I made this toy like in the 1990s, and it's a geodesic dome. It's an example of a geodesic dome, and I really like this geometry because it's based on the golden mean ratio, and so it's very resonant. And I want to have one of these myself, and we're working on making this a dome out of basically diamond-shaped panels. The ones I'm working on are 1.2 meters across, which will make a 3.5 meter diameter little dome, a bit like a yurt, and it'll be over 3 meters high as well. And so this is a smaller panel, but I cast this panel in the same shape. This is actually made out of sorrel cement and sawdust. So the sawdust is a byproduct. The sorrel cement is a supplement, so you could basically eat it. It'll be hard on your teeth. And I plastered this side yesterday with a geopolymer plaster. And so that's an example of what could be all stuck together to make a shape like that, as one possibility for how you could use it to make a building. But you could make buildings in all sorts of different free form, you know, like any shape you like. And incorporating 3D curves actually adds strength. So rather than building straight and square, you can start building curvy and just whatever you want, really. But there's, you know, so there's lots of different ways you can go with this. So one thing is panels, and another thing is just generally making it possible to build out of local materials.
So you could effectively 3D print a home with this.
You probably, yeah, people are already doing 3D printing geopolymer. But they've got lots of investment.
Yeah.
It's coming.
Investment is starting to come. Yeah. Any questions?
What's
Yeah.
the water like? Are some of these compound panels things that you're working with, do they like water? Do they repel water? Do they take it in and let it out?
Sorrel cement's like concrete. It sort of absorbs it, but then when it dries out, it goes out again, and it can do that many, you know, every day, and it handles it. But if it stays permanently wet sitting on the ground, you can get microbial action breaking down any natural fibers that are in there. So it really can't be just left wet permanently. Whereas geopolymer can. So it's like basically rock, because the type of bonding in it is covalent. So water won't dissolve it. Water will eventually dissolve sorrel cement bonds. So geopolymer is the higher quality, but it's also harder to work with, and it costs more. But it provides, you know, natural, non-toxic building materials that are going to last. So that, you know, may as well make it last if you're investing your life energy into it.
So you had a vision of, say, building a building or a yurt or a dome structure using panels like that.
Yeah.
So are they rainproof?
Yeah.
Hmm.
Oh yeah, they'll be waterproof. Totally, yeah, and they'll breathe.
Earthquake proof.
Fireproof and waterproof.
And fireproof.
Yeah.
Are they breathable?
And mold proof
Are they breathable?
and breathable.
They are breathable.
And you can eat them.
Or you can have German pig beds and treated timber. Your choice.
Hang on,
right.
let's go over.
What's the thermal conductivity? Have you done any work on that at all?
It's amazing. Like, I've made little panels and put them on the gas stove and left them down there for 10 minutes. This is panels with hemp hurd in them, with the hemp hurd facing down. And after 10 minutes, it hasn't caught fire. It goes black, of course, but you can put your hand on the top of it, and it hasn't got any hot. It hasn't got hot at all, and it's only this thick.
You don't have any numbers yet, right?
No,
If you want to.
Other people have.
Gotta get some numbers.
and Twine's got numbers.
That's the.
Well, we don't
Yeah,
have
let's go in.
Cool. All right, Dura, you had a question. So you would recommend sorrel probably because the walls, because it's cheaper, it's lighter than the
the polymer?
Yeah.
And then, you use sawdust. Why did you use sawdust?
Because it's what I had.
Okay, so would you?
It's what I
prefer
could
to-
get.
Yeah, okay, so would you prefer to use hemp?
Yeah.
Okay, cool, yeah.
Can you crush it and reuse it?
So you can, anything that's left over, you can just put into the next mix. Or you can sweep it up off the floor and throw it in. You can throw all sorts into there and it doesn't really seem to affect it much.
Outside?
Is there a downside?
I'll leave.
It can be dusty. So either have some ventilation or a mask. And the materials are slight, like cement, they're alkaline, and so it's probably a good idea to wear gloves when you're working with it, but I don't. Because I've got rough hands.
You do now.
So you're not using lime at all?
Hey.
You're not using lime?
At this point, I'm not, because I've already worked with lime and I know what that does, and I'm just exploring how things can combine with that. So like, it could be that lime can be incorporated, like you can work with geopolymer, like you put a geopolymer render over a hempcrete building.
Right.
And it would stick well to it, and then it would waterproof it. So then it, it's not going to deteriorate if you get weather on it. So that's why I'm really into geopolymers, for that outer coating.
Yeah.
And also it makes really nice rock, so you can polish it. Because I've been a tiler for the last 25 years and worked in the building industry and seen how much rubbish goes in the skip. It's unbelievable. I raid the skip quite regularly.
Yeah.
So
Okay, so the next question is Debbie. And then
about
Vera,
using
and then
it
Sol.
Yeah,
You know, like, we are.
and baths and basins. Yeah,
Yeah.
we had a go at making a bath a few weeks ago, but it was a total fail. We dug a hole in the beach, in the sand. We made the shape of a bath in the beach, dug it out and sculpted it and got it all good. And then we made a sorrel cement liner that we were going to take out and take home, but it didn't set. And I think that's because the beach was so wet, and also the sorrel cement that I was using was old, and I found that it wasn't performing the same as the fresh stuff. So we took it out, 3 of us took it out, and we just held it out and it went flop into like 100 pieces, and it was like, oh, okay.
So next is here and then Sol.
The hemp thermoregulating, is it fiber? Or like,
Repeat
sorry,
question.
the hemp thermoregulator, it's a thermoregulating fiber, is that correct?
So is hemp a thermoregulating fiber?
So
Well,
it's free.
you're using the herd for the thermal properties
Yeah,
because it's very, very light. It's like the polystyrene.
Yeah.
And so you really want your walls to be quite, well, I'm going for really, really lightweight, insulative, and then putting a hard surface on each side.
Yeah.
So I'm not going for thermal mass, I'm going for insulative.
Sol.
So theoretically, not that it's not for you to do this, but because a student before the sustainable living course was discussed what she worked in the building industry, and she discussed it as you were with the waste. So which is all pretty much toxic, but I guess one option could be that it could be blended into fine particles and then
What?
added as that could be turned into a geopolymer.
What could?
All the waste from the building industry. I'm not saying for you.
Oh, yeah.
But as a step from where we are right now, we could take all that material instead of putting it in a landfill. We could literally put it through a grinder, blend it up, and then add.
Or with plastic, we can melt it down and spin it into microfiber and then just mix that in.
Yeah,
And
it's
it's, yeah.
weird they don't do that. It's weird that they don't
I've
reuse
done
the plastic.
And also that geotex, that's what, so those ones that were dipped that I'm passing around, they're made of geotex, which is basically just spun synthetic fiber, which is what polar fleece is also made out of. And yeah, that incorporates really well. You can actually make good materials out of that too. So
that's this one over here, that rough.
no, that's hemp. No, those sort of those shapes. Yeah,
Cool. Yep, we have a question in the, over here.
that's sorrel and sand, silica sand. Yeah.
Sorry, say that again.
Have you tried air and training?
Aaron.
Yes.
Getting bubbles in there?
It's a subject that I've tried very briefly, but I didn't get very much success. I think the magnesium pops all about. If you use foam to make it, who asked that question? Oh yeah. If you use mix in foam, it seems to just dissolve it, and it's like you lose all that volume.
No, air,
That-
not foam, air.
Yeah, so that's another way of doing it. And then there's the sort of the chemical way of doing it, where you mix in something that reacts, that releases gas.
Yeah, yeah.
And so I haven't done that one either, but I am really interested in aerating it for lightweight. Although you can also mix in herd to make it lightweight. So
Cool, yeah, over here.
In talking about your structure, the proposed structured panels, for exterior cladding, how thick would these things be? Are we talking like,
depends on the size of them, really. Like I'm not, if you only want to make something 3 meters across, you don't want 300 mil thick walls because the space in there will be so small. So I think for a big house, you probably want nice thick walls and it'll regulate the temperature. But for small things, I'm just going to make the walls like 80 to 100 mil thick. Like,
so are you planning with your structured panels having a range of different widths and panels?
Yeah.
Yep, for different purposes.
Yeah.
And would you cut the holes into for windows and doors, or how that work?
can do, you can cut it with a handsaw, or you can cut this with a handsaw. You can box them out. Depends on what you're building. But you can also cast all the window frames and set glass into them, like cast them in one piece, and they'll be like rock, and you can put fiber in there and you can make them whatever color, and you can carve it and take a mold off that. So all your windows are carved, all your window frames are all carved. A lot of possibilities.
In the back.
Is there any weakness in regards to, like, say, pouring, say, with like granite, like pouring it, and then once it's set, going pouring it again? Like, do you have to have it all sort of poured so it all dries at the same time, or can you pour a structure block at different areas and still remain like,
And have them well together, sort of thing.
yeah, or just does it weaken if it's not all poured at the same time? If it's supposed to be in a single block.
Good question. I think that you can mix up geopolymer that is so sticky that you can use it as a glue. But I've got one more. So this is a bit old, but this one here, I just basically took 2 pieces of plywood, mixed up some sorrel cement, stuck them together and clamped it and left it. And I've had, over the last few years, met quite a few friends try to pull this apart, and they haven't been able to. So it works as a glue for gluing straight onto wood, and it'll also anything natural. So it glues, yeah, pretty much. It will glue 2 bits of rock together. The only thing it doesn't stick is plastic. It doesn't stick to plastic, so it's really good for using for molds because it just comes straight out of plastic.
What's in there?
So this is just 2 bits of plywood stuck together with some sorrel cement, and then I made up some paint by just mixing some coloring into the sorrel cement and painted it on. So this is several years old, and it's been out in the rain. It's wet at the moment, and only half of it is glued. So I imagine it will come apart quite easily now. But as an example of, you can use sorrel cement or geopolymer as a glue to stick things together as well as make the original thing. So I think you should be able to build it up.
So
Theoretically, if the Egyptians made their blocks, or their blocks, would they have had to pour 3 or 4 ton blocks all at once, or could they have over a few days poured and filled up and made a block and keep the same structural integrity, or did it need to be kept the same?
I don't know.
we've got time for one more question, and
wasn't there.
that'll be. Mine about big cake.
I'd say that you want to make 1 block at a time, and then you could stop, and then next day make another one right next to it. Wait till it's a set, take the boxing off, pour the next, shift the boxing over, pour the next one, take the boxing, you know, so that looks like that's how they did it, or that's what the benefits reckon.
What it seems like it's really solid, especially the really thick ones that, like if you're building something with the really thick walls, what happens with an earthquake? Is it flexible or will it break up if there's an earthquake?
Well, it's full of fiber, so it should be really good with the earthquake. And all the
Right.
joints will be fiber reinforced as
Okay,
well,
so
so
it'll be flexible then,
it'll be
even
rigid.
though it doesn't seem to be when you pass it round.
Yeah, no, it'll be pretty rigid.
It's rigid, but it doesn't break up.
I think it'll just be really strong. It won't,
R&D.
yeah, we gotta prove all of that stuff. Yeah.
Okay, yeah, one last question, and then we're gonna.
In terms of cost, have you done any work to see like how, I mean, I'm thinking I built 2 houses in the Hebel blocks, which are aerated concrete blocks, which same thing, you can cut them, saw them, shape them,
Cool stuff.
really cool stuff, but super expensive. Have you guys done any comparisons like in terms of costings, or is it just too hard to do that at the moment?
Well, the ingredients are, you know, you buy it by the ton, and you know, you're talking about $300 or $400 a ton, and then you've got your hemp. So that's a lot cheaper than Hebel.
Yeah, I guess
But there's labor in there as well, and so it all depends on what infrastructure you've got as to how economic it is. But you could, if you know, a person that wants to build a home for themselves could get in a truckload of hemp, the ingredients to make the binders, and then build every single part of it, pretty much every single part of their house. And the cost of materials would be like under $5,000, or you know, definitely under 10. And that's not counting glass and pipes and wires and stuff like that, and appliances, but
The basic.
the floor, the walls, the roof, the doors, the joinery, anything you want to make out of it, you can. And you're just paying that $300 a ton for your materials. So it's, you know, it's like your material cost for a whole house might be 10 grand. So then the rest is labor. And there will be a lot of labor in there, but you're going to make a better house too.
The communities that probably most people here in this room are thinking about, smaller houses in communities as far away from civilization as possible.
not entirely. There is that element, but there is also the element that Andrew was talking about is using the technology for aerated concrete. Usually is done under larger scale fabrication.
Yeah.
Whereas we are going for more localized, and of course adding that natural fiber to the building product adds that actual, you know, regenerative element that we've all been talking about, you know, through the whole scale of the process. But yeah, the research and development that we are going to be doing over the next year is going to be covering, of course, the basic panel structure as one, and we will be doing tests for earthquake loading tests, for compression, for flexural tests. We're going to be doing all of those tests. But at the same time, you know, this is just kind of the gateway research project to all of the other things that Andrew has been working on, which is things like, you know, tiles and bench tops and, you know, door frames and doors and all of those other components. Because I think that mutually we both agree that how cool to be for the whole house, from, you know, from your wall to your doorknob is all geopolymer and hemp. So yeah, so
clay and sand
and all of those components. Absolutely, that absolutely, yeah. So there's a big scale of things to research. Yeah.
Yeah, that's all. Brilliant, thank you. Oh, yeah,
One question for Antoine.
okay.
You didn't mention the targeted cohousing common house. And I thought that
Thank
might
you
be
very
one
much.
of
That was very rude of me to have left out. Yeah, so what we do have as much as the 70 houses is the big vision goal, and you know there's a lot of process that we have to go through to get there. Kohu has landed the first contract for the co-housing development of the Takake co-housing, which is going to be a big community hall, 250 square meters, 68 cubic meters of hempcrete, which is officially going to make it the biggest hempcrete structure in New Zealand. So that's going to be happening this September, and we'll be running workshops. So it'll go through the emailing list. You can get on board, do a weekend workshop. We can get your hands dirty and into the hempcrete. We will be doing that the more traditional way still, as we've still got the R&D of these panels to do. Yeah, so that's coming up.
Yeah.
So-